we're going to go through a complete guide to choosing the right AMR for your material handling needs. My name is Tom O'Neill. I'm a product manager here at Otto. So we're going to start off with thinking about tomorrow and beyond. Then we'll talk about the 7 things to consider when automating a workflow. Then we'll have some questions that you can ask your AMR vendor and how the biggest brands are using AMRs with some example case studies that we have. And I do want to stress that this is coming from Otto, but it is supposed to be a generic kind of question answering seminar. If there are things that I talk about that might be auto-specific, but they're trying to be more just generic for the market itself. So you can ask any AMR vendor these questions and consider the pros and cons between everyone else. So thinking about tomorrow. So material handling has been a crucial aspect of the manufacturing distribution since ancient times, and one of the biggest consumers of labor. In the past, people used like manual carts, manual labor, or other tools to move goods, which got through low throughput and safety incidents, and a lot of the times high operation expenses. In recent years, we've started moving towards significant advancements thanks to innovations in the field. AMRs is one of those innovations. But today, AMRs and other of these kind of innovations are helping to save money, improve efficiency, and keep people safe, which is one of the biggest aspects of it. Now, as we progress and start to look beyond what we're having today, we can look at things of where the industry is going. And there's a lot of indications towards the digital transformation and information and streamlined information decision-making, as well as that real-time material visibility. There'll likely be an increased adoption of autonomous systems. But so this is why it's good to start to question where your facility is going to go in the next 5 years, and how will you either keep up with these changes or how you're going to fit into that space. And this is especially true in the manufacturing space. The adoption of Industry 4.0 will create winners, increase competition, and a lot of the times you need to innovate in order to survive. So it's really important just to start to think about where things are going, what you're doing about it, and how AMRs can help you with that. So selecting the right AMR for your needs. So we're going to start with the basics, and then we're going to work towards the more complex. So starting off, we'll go through payload and then use cases, get into the facility and throughput side, and then as we go on from that, start the scaling up towards fleet manager, ease of use, and then after the fact, maintenance and optimization. So I'll provide some context about why these are important, and then we'll include some case studies and some specific examples. And by the end, we'll have a checklist of things that you can ask people in order to implement an AMR system. I'm going to start off with payload. This kind of seems pretty basic, but there are a few points to take into consideration. Let's get into it a little bit. It seems obvious, but at the end of the day, material movement is about the material that's being moved. So there's some kind of raw material that needs to get from pick out to pack out, something that's within your material manufacturing line that you need to go from station A to deburring station C, or a shipment that needs to get out the door by 3 p.m. today. Whatever it is that's being moved, you really got to just narrow down what that specific situation is. That comes down to things like dimensions of the payload itself, the height, weight of the payload itself, which is overall just the general mass, and then the center of gravity. And center of gravity is something that's a little bit harder to define sometimes, depending on what you actually know. But identifying that really helps with a lot of the vehicle dynamics. So a lot of the times with flatbed AMRs, if you put 1,000 pounds right at the front corner, you might disrupt a little bit of the balance of the vehicle itself. So knowing that center of gravity is important because you want to have it as center of the vehicle as possible. So again, it's a basic setup, but it's critical for how vehicles operate. And a lot of the times, AMR vendors also classify their AMRs based on the capacity type. For example, Otto has the Otto 100 for 100 kilograms, the 1500 for 15 kilograms, and a lot of the other AMR vendors have similar kind of setup as well. So knowing that payload, knowing the dimensions is definitely the first step. So now that you know what it is that you're going to move, we're going to talk about the use case for it. So it's basically the how, what, where of how it's moving. So we have a couple examples here that are split out into different situations. On the far left, we have bringing materials to and from people. An example of this might be like in automotive space, picking warehouse parts and putting in jobs elsewhere in the plant. A worker takes small components, puts them onto a cart, and then an AMR comes and picks up that cart and moves it along. Another example is where it's an Otto or another AMR would bring this part to an inspector, and then they would choose them to send to line side and or rework. Really, all of these things are just basically what's your pickup point and what is your drop-off point. In the middle, again, we get into bringing materials to and from some automation equipment, so like a palletizer to a stretch wrapper, or something that's a little bit more of a less human interaction based. And we'll get into some videos about these first two a little bit more in the next slide. Finally, we have moving materials to and from racks near the floor. So this is new, especially for auto motors, but in general, picking up from line side to pack out or finished goods, finished materials pick up as inbounds coming to your dock, so pallets coming off of a truck, moving that to storage or to wherever it needs to go, or cross-dock transfers. So now we have a little video. This first example is of a customer that we have called Cober. They have a print and paper moving operation. So they're doing a lot of that moving from person to person. So they want to move partly completed orders from one person to another. Before, they actually had a person moving a cart by hand all the way around. And then now they have the AMR that's moving it from side to side. And then next we have Amway. So Amway's focused on consumer goods. They have a 1500 with a conveyor attachment on top. So this is more of that automated system with pallets. So connecting to a line side conveyor, that conveyor automatically triggers when a pallet is available. The AMR picks it up and then moves it from one conveyor on one side of the facility to the palletizer stretch wrapper. This also has some integrations as well with the facility with opening automatic doors and that kind of setup. So this is very much more of a fully automated system. Okay. And then finally, we have kind of a more specific use case again, which this is Dan Foss, again, another AMR vendor or AMR user with a 1500. And this starts to get into, again, more use cases and what problem that you're trying to solve. So Dan Foss in particular, they were looking for how do we move more with what we already have with the context of their facility, like how do they optimize their floor space for material flow and get the maximum output without moving everything around that they already set up. One of their biggest challenges was day-to-day operations was labor shortage. And of course, like most people in the world, they value safety above all else. So that was key when trying to pick an AMR solution because it had to interact with humans. So they want to work towards a solution that would have something that's more flexible and safe and can carry them into the future. They went with automotive specifically because they were seeking these labor efficiencies. And they had that AMR that was specifically for their payload. So that's a big factor as well. Again, it's just identifying the payload that you need, which AMRs suit that needs, and then what other factors are for that vendor. Next, we'll get into more of the facility side. So we know what we're picking up. We know the endpoints of where it's going to go. Now we're going to talk about where it's traveling through. On this slide, we have two different examples of facilities. The one on the left has a lot of fixed infrastructure. You can see that there's everything built in and solid. And then the one on the right has a lot of moving boxes and things that are placed all over the place. Both can be automated and improved by some AMRs, but they have very specific different interests that they would need to have in order to implement an automated solution. Again, for the left side, we don't want to change any of the infrastructure that we already have, so we have very fixed points. This is great for AMRs as far as localization because they can drive around and know where everything is with these fixed points, but there might be a lot more congested space and very limited aisleways. On the right, a lot more open space, which is great to have AMRs travel at full speed, but things could be moving a lot because there's pallets that aren't necessarily fixed. So you have a lot of dynamic areas, and AMRs generally use what's around them to localize. So having those dynamic areas could be potentially an issue for certain AMR vendors. Another aspect as well with just AMRs, notice the aisle width. Generally speaking, the AMR size itself is not how big the aisle needs to be. It also has its digital size or its safety field size, which is potentially quite a bit larger than that AMR. As it's driving down an aisleway, because it's supposed to interact with people, that digital footprint will increase as it projects forward and allows itself to have a proper stopping distance. If your aisles aren't big enough to accommodate that, you might have an AMR that can boast a top speed of 2 meters per second, 3 meters per second, but only ever go like half a meter per second because the aisles are too narrow for it to actually get up to that top speed. So what your facility setup is and how all the turns and everything in it are really important to match with an AMR. So getting right into that, we're going to talk a little bit more about throughput. There's a couple of different evaluation criteria when we're talking about throughput. We know what we're picking up. We know where the endpoints are, what we're traveling through. So now it's how much or how fast we need to move things. So this is where we make that change from, is a single AMR enough, to maybe I need to have multiple AMRs. And this is where our complexity can start to scale up. How many parts are needed at the line to maintain production? How many parts fit on a single cart, a single pallet? Can your AMR pick up that many parts, or does it need to be split up between multiple AMRs? How long will it actually take to get from A to B once you have that aisles and all that understood? After that point of kind of what your facility setup is going to be, you get to the realities of AMRs. We like to talk about how AMRs don't sleep, but they do charge their batteries, or you do have to have a battery swap. That adds takt time to the overall process, because there's not, at any given point, an AMR might be charging. So knowing how fast an AMR does charge, or the battery type that is using, if it is automatic charging or if it's like hot swapping, could be critical to make sure that your fleet is sized appropriately. And then you get into things like if you have buffers or how many actual vehicles you need. And one other thing that I do want to stress, and we talked a little bit about it in the facility side, but average speed is the key indicator of how much throughput you can get. A lot of the top speeds for AMR vendors are fairly similar. They're around the 2 meter to 3 meter per second mark. But anyone can go top speed when it's a wide open alleyway or aisleway. But it's really the turns within a facility that affect that average speed. It's really how many people are walking in that area, or if there's traffic lights that the AMR needs to stop at. All these things affect that average speed setup. And so having a known average speed is really a more key indicator than the top speed for an AMR. And just a bit for the Otto side, Otto actually has a service where we do fleet sizing that does account for all these different buffers and modifiers to help know exactly what the minimum amount of AMRs needed is to complete a job. So that's, again, you get into some of the things about overall price points with this conversation, because hey, maybe you need to buy one AMR from one vendor and their cost is 50% of the cost of another vendor, but that other vendor is maybe you need 2 or 3 or 4 in order to do that same amount of work. So that fleet scaling, when you get into some of the larger projects, is important for that overall cost. So speaking about fleet scaling, now we can talk about fleet management a little bit. So we've determined that we need more than one AMR. Now we're going to need some kind of a software to manage all those AMRs that we have. And this starts getting into talking about scalability and what it's going to look like in the future. Many companies have a fleet management system that can coordinate and report on the status of the multiple AMRs that you might have to deploy. What you consider a fleet manager is a traffic coordinator, a translator, and a team leader, all in one little box. This allows you to get into some of the more powerful applications like the traffic management. AMRs require some efficient routing and scheduling to make sure that they are completing tasks on time, and a fleet manager software can do that for you. For a lot of AMR companies, the actual navigation, like you can see all the lines in the video here, the actual navigation isn't done on the fleet management system. That's done on the actual robot itself. But the fleet manager does things like pick which robot is going to go and do a pickup and drop off point, or determines that this robot's charge level is at 50%, it's now next in queue to go to the charger. So all that coordination and how they interact with each other is done on the fleet manager tool. And scalability as well. It's in the pro tip, but depending on the size of fleet that you are going to have, you should look into what the fleet manager capabilities are for that fleet size, because there can be, as you scale up, the fleet manager still needs to coordinate all the different AMRs that are on it, and that can cause slowdowns for some AMR vendors. So understanding the right one that suits your needs is important there as well. And then finally, we have the integrations with the existing systems. Again, for Otto specifically and a couple of other AMR vendors, the fleet manager side is how the integrations come with your warehouse management system or whatever other integrations that you might have. For some of the use cases, we saw a pallet come to an end stop of a conveyor that triggered a PLC sensor on that conveyor that went up to that whole WMS system. And then from that system, that was the communication point to the fleet manager. And that says, okay, there's a pallet here ready to be picked up. I'm going to choose this AMR to go and pick that up. So the fleet manager does a lot of that kind of coordination with whatever systems your facility already has. So now we understand that we potentially need a fleet manager. Ease of use is one of the key factors as well when choosing between AMR vendors. So you really have to ask yourself, who is going to be using the system? Is it going to be your top engineers, or is it going to be line side? Who's actually going to be interacting with that system? The video here shows an intuitive system of how easy it is to place a pallet down. So you can choose a pallet endpoint, put it down and say pallets are being picked up from this position. That's great for initial setup. How it looks like for the actual operator using it or things in the future are all things to consider when you're looking at what the UI actually looks like. So you can also talk a little bit about who you don't want to use your system. We have infrastructure that you have maybe some specific needs for, some IT security, access management, where a fleet manager is actually being housed. Is it local? Is it in the cloud? Is it at the AMR vendor's facility? All these things are different depending on which AMR vendor that you go with. You can ask those questions of, how does someone access my system? How can someone outside access my system, or can they? Do you have encryption management? All these things. And that gets into a lot of the future of AMRs in the innovation space, where we're talking more and more data centric. And so then we're talking more and more data security. And then finally, we're going to talk about the maintenance and optimization side. Great, you've implemented a system and everything's running, and it's going to keep running forever. Nothing's going to break. Doesn't really happen like that. So things sometimes fail, breakages occur, something happens, or that your system is starting to not behave with the throughput that you originally had when you set up. So what those tools you can look at are either some like triage and diagnostics or some analytics tools. AMR vendors have a variety of these as well, so that you can actually look back and see what happened at this specific time or the specific area. The video here shows what our analytics tool looks like. You can also do a deep dive with our setup to see exactly what the robot saw at that time. So you can see maybe at 10 p.m. there's some slowdown, and you can see what the robot was seeing at that time to see why it slowed down in that area and why your traffic had an issue. We actually had a situation where a customer was actually getting slowdowns as soon as night shift started. So then they asked us to take a look. We were able to narrow down that time window to about that 10:30 to 11 o'clock window. And then we were able to see what the AMR was seeing at that point, just in a digital space, not actual like cameras, but just cloud points on a plane, able to determine that there was some kind of obstacle that was blocking the aisleway right at that time. So we told our customer about that. And it turned out that when the night shift manager came into work, he parked his forklift right beside his desk in the aisle. So then that was slowing down the AMRs because now they had to try and squeeze around it or find another path. So we asked them to move that forklift as a trial. They moved it, and then their throughput went back up to normal. So all these things, after you set up a system and things are clean, they can degrade over time as either different human interactions come or the facility starts to change over time a little bit and things start to move. So having that after the fact optimization and analytics really help determine where those issues could occur. And it can also really help prove out your ROI, seeing that I've actually moved 20,000 pallets in the past 2 months. It really help prove your use case. So this is just a quick look at some questions that you can ask your AMR vendor before you buy. What are the largest production deployment your vendor has ever done before? Can they talk about it? Are traffic rules configurable, or are they fixed? Does it matter which AMR you're talking about to have specific traffic rules or not? And then you get into performance questions like, Can the robot pick between equivalent destinations if the destination itself is blocked? Can queues for payload transfers and robot chargers be specified? All these questions you can ask your AMR vendor and then try to use that as a comparison point. We're going to see how some other people have been using AMRs. So these are a couple of use cases with just some maybe well-known brand names and how they've used at least Otto AMRs. So we're going to start off with GE Healthcare. GE was really looking to improve the efficiency of their floor space. So they had an inefficient material workflow and a lot of wasted space because they had all this fixed infrastructure and some bulky carts. So they came to Otto and we worked with them to do this deployment. And the turnaround was they had a 40% smaller repair cell because they didn't have to have all that fixed cells, all the fixed components actually there. They could have things move around more, so then space was sometimes more available. They also enabled them to put other integrations and other innovations in those areas. So overall, it actually increased their productive floor space by 66%. This is one of the possible reasons for getting an AMR, which is more efficiently using your floor space, but there are a couple of other reasons as well. Forcia, or now Forvia, reduced their work cells by 15%, and they got, at least with Otto, an 11-month ROI, which is really good. So before they had tuggers and AGVs to move things, they wanted something that had a small footprint because their aisles were very variable and congested a little bit more. So they want a solution that had timely moving materials with minimal downtime, and they can just kind of let the AMRs do their thing, not have to have that hands-on support. So they had a higher, besides the reduction in work cell sizes and 11-month ROI, they had high response lead time. So basically, overall, all of their operations improved because they could get materials to them a lot quicker, which is, again, that material flow where the facility is important too. And finally, we're going to talk a little bit about Mauser. Mauser actually had it almost seems like a fake number of 600% throughput improvement, but they decommissioned an AGV system that could only do 3 or 4 movements before it actually had to go charge. Then it took 30 minutes to charge, and then came back and did another 3 or 4 movements. The Otto system that they replaced with that could move up to run continuously for 36 missions before have to go into a charger. And then it would charge within about 5 to 10 minutes up to that 70% level, and then could keep going again and again. When I was talking before about that charging and how long it actually takes, that can be a really big factor in your throughput movement. Overall, the max runtime for the Ottos at that facility too was up to 13 hours. So they got basically half of a full 24-hour day of just continuous running before enough charger stack up had to start charging. So they moved from manual labor and that AGV system to an AMR system, and they actually started to improve safety at their Langley facility out in Vancouver, Canada. And then they also installed another facility in Oakville, Ontario, Canada. They saw the value and they kept moving and improving with it. So key takeaways. This is a checklist of everything that I talked about today. And again, use this as an example. Compare every AMR vendor that you can find on the market with all these different things, and just try to find which AMR vendor is right for you. There's a lot of different variety of cost points, a lot of different variety of features and functionalities and support structures as well, depending on which AMR vendor that you're engaged with. You can ask all of them a bunch of these questions and just see how they stack up with each other and see which one is right for you. Because at the end of the day, like I said, you're going to have to deal with a system that is implemented, so you're going to make sure that it needs to fit your needs. We're almost finished today. If you want to contact Automotors, you can either find us at the website or call us. You can also visit us at some trade shows. So again, you have the chat in the side. You can ask any question, and then I'll see them come up. When firmware is updated on the Fleet Manager software, do the AMRs also need to be updated software-wise? This depends, again, on the AMR vendor. For Otto itself, for example, we launched 228. We do have the 228 software for the AMR as well as the Fleet Manager. As of today, yeah, they do have to be updated together. There are some minor updates and configurations that you can just send down from the fleet manager to the AMR itself. But in general, yeah, they try to keep it on the same software stack so that they have all the connections match up. So many AMR companies advertise their units per hour or deliveries per hour metric for the AMRs that's based on ideal conditions. How do you suggest we work with AMRs during the vendor selection phase to get the best idea of expected throughput for our specific application? Yeah, and that's true. There's a lot of cases where they analyze the ideal setup, but nothing's ever ideal. I guess some of the questions you can start to ask or see for AMR vendor selection is, are they asking you for the specific floor layout that you have and the paths that are there? Can they answer questions around how their AMRs interact with different floor coefficients of friction or those kind of things? So you have slippages, the environmental conditions as well, which can be a factor. Do they have a works down from -50 to +100 degrees Celsius or some crazy metric, or is it more specified, and what does happen at the limits of those ranges? Have they tested those ranges? So I think you start to get into asking for some more specific questions, and I get these all the time from our customers. But if you get into some of those more specific questions for your application, you can see if the answers are more of just yeah, we can do anything, or well, actually, this is how this affects us. And so you can get more of those real answers out of it. It's a good question. There are no specs on most of the autonomous vehicle vendors about the time the vehicles need to locate precisely at a specific destination, plus the time it needs to lift in case of flat ones. How can we estimate that cycle time? Or is it just by demo on site that we can validate something like that? Yeah, so that, again, get into those specific questions that you can ask. There's some things that you can just ask if that's a factor for you to your AMR provider. I know that when we do our fleet estimation setup, we have specific things like time for endpoint actuation. Dealing with AMRs, there's the flatbed portion, and then there's the attachment portion if it's not integrated into it. Otto has a variety of different attachments on top of them, like a couple of different lifts and conveyors and the like that we use. Each one has a variable interaction time depending on the type of attachment that it is. So right now I'm working with a vendor to make a pallet lift that takes about 3 seconds to move up and move down. Previously, I've had a pallet lift that's taken 20 seconds to move up and down with a longer stroke. So when you're speccing out what AMR you need, you can also ask questions around what type of attachment is, and then ask those specific questions to the vendor. The localization one's a little bit more tricky because it comes down to, it depends on if you've completely changed that environment over time or recently to see that the vehicle would get lost in that area. I think that there's some videos that we have at least that can show relocalization time. But if you want to send an email with that question as well, I can get you a more clear answer. Thank you again for joining us today. Really appreciate you taking the time.